and comes back, he can still like write it down from
There you go. Yeah. Kevin, are you back? Yeah, but he's eating his sandwich probably. Okay, so rules of differentiation. So there's something called a power rule. Used all the time, every day, the rest of the year. So you can imagine trying to find the derivative of this using a difference quotient. You'd have to do x plus h cubed minus 4x plus h squared plus 10 times x plus h minus 1 minus all that stuff over h and then evaluate the limit. There is an easier way. Anybody know what the derivative of x cubed is without doing the whole difference quotient?
3x squared.
3x squared. Good. So we got 3x squared by dropping the 3 down and reducing the exponent by 1. So 3x squared. So minus 4x squared, we could bring the 2 down. So it's minus 8x to the first. You can imagine this as 1. So 1 times 10 is 10. X to the 0. X to the 0 is just 1. Another way of thinking of that is derivative of a linear is just the coefficient, that's a slope. And then the derivative of any constant is always 0. So there is my derivative using the power rule. So technically, the derivative of x to the n is nx to the n minus 1. And if there's a coefficient out front, then you just multiply. So like if there's a 3 there, 2 times 3 is 6x to the first minus 8, and there's my second derivative. So there's y prime, there's y double prime. We're on a roll. Might as well do a triple prime. And just because I want to do Roman numerals, I'll do another derivative. So I get 0. Okay, so that's the power rule. When applied to a polynomial, it's very straightforward. There are other applications for the power rule. So if I wanted to find the derivative of square root of x, you can use the power rule. But you have to change the way it looks. Square root of x in exponent form is x to the 1/2. So now I can find the derivative by dropping down the 1/2. X to the, well, we have to subtract 1 there, so it's negative 1/2. So 1/2 x to the negative 1/2. Well, we don't like negative exponents, so I'll put it on the bottom. So it's 1 over 2x to the 1/2. And x to the 1/2 is the same as square root of x. So there's the best answer right there. Yep.
Would you want us to rationalize that or no?
This is the answer I want right there. You're saying to get rid of the square root on the bottom?
Yeah.
That's a silly thing. No,
Okay.
this is better than doing that.
Okay.
With the one on top, with the polynomial thing, when it was just 1x, it just turned into just like itself, like an infinite, but it's top of an integer. But then here, it didn't.
So what?
I'm confused about that.
Tell me again.
So when we derived that polynomial from above, and
Yep.
it was, and when we did the 10x one, it just turned to 10.
Yep.
So why wouldn't it do the same thing with the square root of
Oh, because this is 10. His question is, the 10x became 10. Why doesn't that work with the square root of x?
Yeah.
Well, 10x is linear, and linear means that you have an exponent of 1. It's to the first degree. Square root of x is not linear because it's x to the 1/2 power. So if there's no exponent on it, then it's linear, but if there's an exponent other than 1, then it's not linear. Did that answer your question? Kind of, sort of?
And then, how did you get the negative 1/2?
This negative 1/2?
Yeah.
So up here, you know that it's x cubed, and we have to bring the 3 down, but you have to subtract 1 from the 3, right?
Yeah.
So we have 1/2. We have to subtract 1 from that. So So 1/2 minus 1 is negative 1/2. You have to take away 1. Good questions. Okay, so another example, I might have like 2 over x minus 3 to the 4th. We can use the power rule here as long as we manipulate what we have. Okay, so we're going to move it to the top. So it's now 2x minus 3 to the negative 4th. And now we can find the derivative. It would be negative 8x minus 3 to the negative 5th. So I would say negative 8 over x minus 3 to the positive 5. Okay? Alright, so that's the power rule. That's an important one. Alright, so if we have, we just demonstrated that if you have a series of terms, you can find the individual derivatives of all of them and combine them. We've kind of assumed that you can do that. Like derivative that, and then just combine them after. Well, if you have the derivative of u times v, is that equal to the derivative of u times the derivative of v? So is that legal? If you have two things multiply, can you just multiply the derivatives? The answer is no, you can't do that. So if you don't want to write this down, that might be confusing. That's not anything we ever need to remember. The product rule is the derivative of u times v is equal to u, I'll say v prime plus v u prime. And the order doesn't matter. It could have been vu prime plus u v prime. But that's the product rule. That's another really big one. So for example, if you wanted to find the derivative of 3x squared times x to the 4th minus 6x cubed, something like that. So if we wanted to, we could find the derivative as it is when you've got something times something. You could also distribute and then figure out the derivative, and I'll demonstrate that you get the same answer. But if we wanted to use the product rule here, it would be u times the derivative of v, which is 4x cubed minus 18x squared, plus v, which is x to the 4th minus 6x cubed, times the derivative of u, which is 6x. So what do we have? 12x to the 5th minus 54x to the 4th plus x to the 6x to the 5th plus 6x to the 5th minus 36x to the 4th. Oh, okay. What do we have? 18x to the 5th minus 90x to the 4th. All right. If we had distributed, what's that?
I'm just kind of confused about the product rule, or I don't really understand. I don't know.
I'll do a couple more examples with the product rule. It's okay that you don't understand it right now. I hope it gets better. So just to demonstrate that a better way to do this problem would have just been to distribute 3x to the 6th, 18x to the 5th, and then find the derivative. It'd be 18x to the 5th minus 90x to the 4th. Way easier than using the product rule. So why would you ever have to use the product rule? Well, you have to many different times. The reason we don't need the power rule here is because you can distribute 3x squared to all that. But if you had like the square root of x times trig stuff or log stuff, or I'll just do another polynomial, 3x squared plus 10. Why don't you try doing the product rule with this one? See if I can pause. Alright, so like I said, this was a pretty hard problem. I should have given you an easier one just to get used to the rules. So the product rule, this is your u, so we're just going to do u times the derivative of v, so that's 6x, plus v, 3x squared plus 10, times the derivative of u. Well, we know what the answer is there, but we'll revisit square root of x derivative. So that's x to the 1/2. So the derivative is 1/2 x to the negative 1/2, or 1 over 2 square root of x. Okay, so what do we have to do? I would combine square root of x, or x to the 1/2, times x, and that would be x to the 3/2, because they have the same base. And then I would probably put 3x squared plus 10 on top, and 2 square root of x on the bottom. That's probably the best way you could write the problem. You could also separate these two, combine the x bases here, but I think this is probably as clean as it can get. Okay, so you can see I'm kind of just, I'm avoiding.
Show that answer just one more time.
Yep. I'm avoiding exponentials, I'm avoiding logarithms, I'm avoiding any trig. So we're going to learn lots of different techniques this year. In fact, this chapter we're going to learn pretty much, we're going to learn every technique in finding a derivative in this chapter.
How did you get 6x to the 3/2?
Because this is x to the 1/2.
Mm-hmm.
So x to the 1/2.
Okay.
You got that?
Yeah, I just had mine as 6x times square root of x, so I was trying to
Okay.
simplify it. Thank you.
Alright, so that is the product rule. You're not going to be completely proficient in it until you practice it, but at least you know what the rule is. Last thing I'm going to show you today is the quotient rule. And that's when we're finding the derivative of u divided by v. I don't talk as u's and v's typically. I do bottoms and tops. But for our purposes right now, the way we define it, it's the bottom, which is v, derivative of the top minus the top, derivative of the bottom, all over the bottom squared. So I will always say bottom and top because I think it's easier to remember that way. But it's always the bottom, derivative of the top, minus the top, derivative of the bottom, all over the bottom squared. So, example, we got 1 minute. I'll go quickly. So, the derivative of, we'll say x squared over 3x plus 10. Alright, so if we're going to find the derivative of that, using the quotient rule, it's equal to the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So now we just have 20 seconds here to clean it up. So I'm going to back distribute, so I have 6x squared plus 20x minus 3x squared, that's my top. So I have 3x squared plus 20x on top over 3x plus 10 squared. There's my answer. Just in time.